Alright, ladies and gentlemen, here is our answer key for our midterm practice test. So number 1, which of these phrases best describes an atom? Well, we know that we have an atom which has a nucleus which is positively charged, surrounded by mostly empty space, and then we also have the negatively charged electrons all around in different orbitals or clouds, depending on what model we're talking about. So our correct answer is going to be 2, a positive nucleus surrounded by a cloud of negative charges. Number 2, chlorine 37 can be represented as, when you have chlorine 37 here, this is in reference to the mass of the atom. That means we are going to have to look for a mass number that has 37. So if we expand this guy out, we'll see that the only choice that has a mass number of 37 is going to be number 4. This is the mass, and this on the bottom is the atomic number. So don't get confused with number 2. This is not the correct answer. That 37 would be the atomic number, not the mass. Alright, let's look down for number 3 here. An atom of carbon 12 and an atom of carbon 14. They are isotopes of each other, and they differ on only their mass number. They have the same atomic number, they have the same nuclear charge, and they have the same number of electrons. The only thing that they differ on is their mass number because of their number of neutrons. Okay. Number 4. What is the nuclear charge of a nitrogen atom? Well, nitrogen, the nuclear charge means just the charge on the nucleus, and so that will be just the protons involved in a nitrogen. And since nitrogen has 7 protons, it will have a +7 nuclear charge. Alrighty, let's look at number 5. The atomic mass of an element is the weighted average of the masses of. Now this is pretty much a definition question. You've got to know that it is all of the naturally occurring isotopes. You can cancel out a couple of these answers because it's not ever just going to be 2 of the most abundant. We don't care about that. It's not the least 2 abundant. That doesn't make any sense. And they may or may not be radioactive, and we don't really distinguish based on that. Alright, number 6, you can cross off. That one used to be covered. It is no longer covered on your midterm. It'll be covered later in the year. Number 7. Given the balanced equation representing a reaction, we have the breakdown of an O2 oxygen molecule into O and O. We have essentially broken the bond between 2 oxygens. Okay? And because the bond is broken, we need to remember BARF, broken, absorbed, release, formed. When we break bonds, we absorb energy. When we form bonds, we release energy. So BARF. I would remember this for your midterm. So in this case, we have a bond that is broken. So we know that we are going to cancel off 3 and 4 because the bond is not formed. And then if we remember BARF, broken is absorbed, and so energy is absorbed as bonds are broken. Let's see, we've got number, let's move this over here. Number 8, we have a bad version here. Looks as if my number 8 is a little different from your number 8, but I have it right here. So your number 8 is 4Fe plus 3O2 yielding 2FeO2, and you are determining what type of reaction this is. So this isn't quite correct, but the type of reaction that this is going to be number 2, which is the synthesis. Hopefully that is not one that you were struggling with. Okay, number 9. Number 9, polarity, requires that you remember that to be polar means to have a difference in electronegativity. So E-neg difference. Okay, and so if you look at your reference table, and you can look up all the electronegativities, the one that is least polar is going to have the smallest electronegativity difference. So we're going to have 0.2 and 3.2, 1.9, 3.2, 2.2, and 3.2, and then finally nitrogen is 3.0 and chlorine is 3.2. So this is the least polar bond. It is the one with the smallest difference. Okay. All right. Which formulas represent one ionic compound and one molecular compound? You need to remember that molecular means covalent. Okay. Ionic is a metal and a non-metal. And a covalent compound is a non-metal and a non-metal. Okay? So in this case, we are looking for one of each of those things. So if we scan through it, we are going to find that 3 is our answer. Number 1 is 2 covalent or molecular. Number 2 is also 2 molecular compounds. And number 4, these guys are polyatomics, so they are ionic. So that can't be our answer either. Alrighty, for 11, we have which grouping of the 3 phases of bromine is listed in order from left to right for increasing distance between bromine molecules. Well, it doesn't matter that we're talking about bromine. It could be anything. We're only talking about the phases. So you need to remember that there is a greater distance between molecules of gas, and then they get a little closer together when they're liquid, and they are very tightly together when they are solid. So if we are looking for increasing distance, we're going to want to go from the closest together, which would be solid, to the next closest, or the next furthest apart rather, and then to a gas where they are crazy, crazy far apart. So number 4 is going to be our correct work there. Which terms are used to identify pure substances? This is a vocabulary question. This question asks you to remember what it is to be a pure substance. It just means that you are consistent throughout, whether or not you are a pure element. You could be. And the only other thing you could be is a compound. So that means if I have a sample of H2O, just because I have hydrogen and oxygen in there, they are chemically bound together. So any thing that I pull out of that water will still be H2O. It is purely just the water compound. And if I have an element, clearly that will also be consistent all the way throughout. A mixture, on the other hand, will have different components mixed in there. So if you were just close your eyes and pick out something from a salad, you might sometimes get a tomato, you might sometimes get lettuce, but you wouldn't necessarily get the same thing. It's not consistent all the way through. All right, so one similarity between all mixtures and compounds is that both, all right, let's go through this, they're not necessarily heterogeneous, meaning different mixtures. You can have heterogeneous mixtures, but compounds cannot be heterogeneous. Homogeneous, compounds have to be homogeneous. Mixtures do not have to be homogeneous. So that one's not true either. Combined in a defined ratio, this would be only compounds. So that one's not correct. And consist of 2 or more substances. Yeah, so in order to be a mixture, you have to have something to mix with, and in order to be a compound, you have to be combined with something. So 4 is our answer. Alright, when a mixture of water, sand, and salt is filtered, what passes through the filter paper? Well, let's figure that one out. If you mix water, sand, and salt, the salt will dissolve in the water and therefore pass through the filter. And so the only thing stopped by the filter is the sand. So water and salt only is your answer. Remember how to separate mixtures. You've also got chromatography, distillation, and filtration to worry about with this type of question. What particle diagram for number 15 represents one pure substance only? Alright, so let's start over with 4. This cannot be a pure substance. It looks like it's a mixture of an element and a compound, so it is not 4. Then we've got a mixture of an element and a compound once again, so it's not 2. Then 3 is a mixture of 2 elements, so nope. And then 1 looks to be a compound, and so that is a pure substance and is our correct answer. Alright, 16. Which temperature would atoms of helium have the greatest average kinetic energy? Well, if we want to know the greatest average kinetic energy, we need to know that that means highest temperature. It is a synonym. Average kinetic energy is measured in temperature. So if your average kinetic energy is constant, that means you have no temperature change. If your kinetic energy is increasing, temperature is going up. Kinetic energy decreasing, temperature is going down. So in this case, you need to notice that this is Celsius, Celsius, Kelvin, Kelvin. So in order to compare these guys, you need to convert them all to 1 unit, and I would recommend going from Celsius to Kelvin. So for this, you are going to take your formula for conversion, which would be Kelvin is equal to the Celsius plus 273. So when you do that, you'll get 37 plus 273, which gives you 310. And that is in fact larger than either one of those two answers. And so 2 is your correct answer. 25 is clearly lower than 37, so you can just automatically get rid of that one. All right. 17. The graph below represents the uniform heating of a substance, starting with the substance as a solid below its melting point. Which line segment represents an increase in potential energy and no change in average kinetic energy? All right, I'm going to label this guy with everything that you need to know about phase change diagrams. So we are going to zoom in on this guy, and we are going to label the heck out of it. So first of all, we're going to do our phases of matter. This is where it is only solid, only liquid, only gas. At the flat here, this is a phase change, and this is a phase change. And so this is where it is solid and liquid. This is where it is liquid and gas. This is also our melting point or our freezing point, and this is our boiling point or condensing point. They are the same, it just depends which direction you're going. Now, the other thing you're going to be asked is about your kinetic energy. So, kinetic energy increases when the temperature increases. So, on A to B, when your line is diagonal, you have an increase in kinetic energy. So, increasing KE. So, let's KE. Increasing KE and increasing KE. Okay, everywhere else, kinetic energy is constant. And then we have our flats. This is where we have increasing potential energy. And this is increasing potential energy. Okay. On the flats, we have KE unchanged on both of the flats for KE. That does not look like a K. Okay. And on the diagonals, your potential energy is unchanged, but I'm not going to write that. So now let's go back to our question. And it says, which line segment represents an increase in potential energy and no change in average kinetic energy? So automatically we know that the only places where potential energy are going to be increasing, we either have BC or DE as our two options. So BC or DE isn't even listed. And so guess what? BC is our answer. All right. What is the total amount of heat absorbed by 100 100 grams of water when the temperature of water increases from 30 to 45. So what we're going to need to do is not make a line. We're going to zoom in so I can show some work here. And so we're going to use the formula because we have a temperature change. Q equals mc delta T. Okay, and we want to know what the total amount of heat is, so that means we're solving for Q. So Q is going to be equal to M, which was 100 grams, C, which is 4.18, found on the front of your reference table, and delta T was 15 degrees. And when you plug that in to your calculator, you will get an answer that is approximately 6,270 joules. Okay? All right, so number 19. A 50-gram block of copper is at 10 degrees. It is carefully lowered into a 100 grams of water at 90 degrees. Which statement describes the transfer of heat? So we always go from hot to cold, high concentration of heat, so to speak, to a low concentration of heat. So what will occur here is that the water will lose heat and the block will gain heat until both are at the same temperature, which is between 10 and 90. Just think about common sense here. You know exactly what will happen. Just think it through and read carefully. 20. Which process is exothermic? Good opportunity to define the word exothermic. So we have exothermic, and it means release heat. It pushes it outside. That would also mean that heat is a product of the reaction. Okay? And on the flip side, we have endothermic. Actually, I'm going to change my things here because this one is going to be hot. And then endothermic in blue is going to feel cool. And it requires heat. So heat is a reactant. So now, which process is exothermic, meaning which one releases heat? The best way to go about this question is to say which one is not exothermic, which one is endothermic, which one requires heat to happen, because there will be three that require heat. So boiling water requires heat, can't be exothermic. Melting copper requires heat. Sublimation of iodine, going from a solid to a gas, requires heat. The only thing that doesn't require heat is condensation. That is a cooling process and is your answer. All right, which mass has 4 significant figures? Our correct answer is number 3. 1, 2, 3, and 4. The zeros in between numbers are always significant. But right now, let's go through and cancel off everything else. These zeros are not significant because there is no number over here making them significant. They are not to the right of both a number and a decimal point. Cannot be that one. There's actually only 2 significant figures there. Same rule goes for number 2. There is no number over here making that 0 significant. You could get rid of it. It would still be the same number. There are 3 significant figures. And over here, because there is no decimal place there, that 0 is not significant. And so there's actually only 3 sig figs right there. All right. Student calculated the percent by mass of water. And let's get rid of that thing right there. In a hydrate as 14.2, a hydrate is a compound that contains water, yada, yada, yada. If the accepted value is 14.7, the student's percent error was. So we need to calculate percent error, and in order to do that, we need to know the percent error formula. So I'm going to write it down here. We have the difference from the accepted over accepted, so measured minus accepted over accepted times 100. It's in your reference table. So we have a difference of 0.5 from our 14.2 and our 14.7. And I will divide that by my accepted value. And the accepted value is the 14.7. And then you multiply by 100 to get a percent. And your correct answer will be number 3, 3.4. All right, a student calculates the density of an unknown object. The mass is this, and the volume is this. How many significant figures should appear in the final answer? All right, so this one has 4 significant figures. This one has 3 significant figures. We need to make sure that we go to the least number of significant figures, and that will be number 3. All right, 24. A 10-gram sample of which element has the smallest volume at STP? This is an odd way of asking which one has the highest density, which one is the most dense. And so what that requires is that you look up all of these elements and you compare their density. And so I'm going to cancel off aluminum right off the bat because aluminum is a very, very light metal. You know it, it's aluminum foil. It's not very heavy to pick up. Magnesium, however that's spelled, is also going to be a very light metal. So now we're to titanium and zinc. And if you aren't as familiar, you could actually look those up, which I would expect. Titanium has a density of 4.5, and zinc, the heaviest one of the bunch here, has 7.1, and is therefore your answer. Alrighty, 25. The reading on the meniscus. We have 30, we have 40, we have 31, 32, 33, 34, 35. We know that this is about 35. But what we can do is estimate 1 decimal place further than the most readable unit here. So I know this is 35, but I can estimate this next place. Okay, I can say that I can fill in this number by estimation. So I'm going to have to say it's right on the line, it's 35.0. I can't say this next place. I have no way to know what this is. I can't read it close enough. I've got nothing to tell me what that next place is. And so my answer has to be number 1. All right, 26. Elements on the modern periodic table are arranged in order of increasing atomic number. I really hope that's just automatic for you. Atomic mass is the olden days. Number of neutrons never was the thing. And number of valence electrons is how our groups are arranged, but not the actual table. All right, 27. Which element is brittle, non-conducting, and a solid at 25 degrees Celsius? Okay. 25 degrees Celsius is basically STP, for the record. Okay, so like normal temperature and pressure, so like right now. Brittle, that's telling me that I have a non-metal. And so automatically I'm canceling aluminum off. I know aluminum's not brittle. Okay, then I know that bismuth is also metal. Done. Can't be it. Now I'm between sulfur and bromine, both of my non-metals. And so now it becomes the solid at 25 degrees Celsius. Bromine is actually not solid at STP, and so it is sulfur. That is our correct answer here. All right, 28. Which changes occur as the cadmium atom becomes cadmium 2+? Okay, what we need to remember here is that when we form a positive cation, that means we have lost electrons, okay? And because it's a 2+, that means he's lost 2 electrons. So the cadmium loses 2 electrons, okay? So now we have canceled off 1 and 2. And then we need to see what happens to its radius. Because this is a cation, typically that radius will decrease. If you lose electrons, generally that's what happens. You think about losing some weight. Your waistline decreases. And so we lose radius. All right, 29. Which element is malleable? Typically something that a metal is. And conducts electricity. Also something that a metal does. So now we are looking for the metal. Not a metal, not a metal, not a metal. is a metal. All right, and 30. Which two characteristics are associated with metals? And this is one that you can either have memorized, but that's not likely. You can check this in the table and just compare a standard metal, pick sodium and compare it to chlorine, and generally speaking, you will see that sodium has a lower first ionization energy, meaning it gives up an electron more readily, and it has a low electronegativity, meaning it does not want to gain electrons, it wants to lose them, which is why these two things are very often connected. Ionization energy and electronegativity, if one is low, the other is low. If one is high, the other is high. All right, so that's it for the multiple choice. Let's move to the short answer. All right, in the modern model of the atom, each atom is composed of 3 major subatomic or fundamental particles. Name the subatomic particle contained in the nucleus. All right, so the 3 that we've got, hopefully you know this: protons, neutrons, and electrons. Great. The subatomic particles contained in the atom, also known as the nucleons. Nucleons are the protons and the neutrons. State the charge associated with each subatomic particle contained in the nucleus. Protons are positive 1, and the neutrons have a 0 charge. What is the net charge of the nucleus? It is positive, and this is because of the protons that are in it. All right, next one. We are calculating the average atomic mass of a given isotope of neon. All right, so what we've got here, in terms of atomic particles, state one difference between these isotopes. All right, so your question is on the following page. Mine seems to be just off a little touch here, but it's the same stuff. So the atomic particle that's different between these guys, it is the neutrons that are going to make the difference. So the neutrons are what's different between these guys. And so now we're going to calculate the average atomic mass. So the way that this needs to occur is by setting it up in a nice, neat way. You are going to take the decimal of the percentage and you are going to multiply it by the average atomic mass. So we're going to do this for each one. I'm going to take 19.99 times the decimal of the percent, so 0.909. Okay? Then we're going to add it to 20.99 times the decimal of the percent, 12.003. Okay? Plus the decimal of the percent, 21.99 times 0.088. And then whatever these guys equal out in your calculator, you're going to write it down and add it up. Alright, so I've got in what I found in my calculator, and I wrote down exactly what I saw in my calculator, as many digits as came up, and I got 20.168 grams for my atomic mass. Okay, and I'm going to take a look at my average here and see the 20 is around 19, 20, 21. It's right there in the middle, so it does kind of jive with what I've had before. If you find one that really doesn't flow with the numbers you have, probably you made a mistake. Alright, let's take a look at the next stuff. Alrighty, so I just did these guys, see previous. Okay, I just have it on the other page. Alright, the data table below represents properties determined by the analysis of A, B, and C, and D, which substance is ionic. Okay, so this means you've got to know the properties of ionic and covalent bonds. Alright, let's summarize them. So I'm going to zoom in here a little bit. And so we're going to go with ionic and covalent. Okay, so ionic bonds, they are typically malleable. They are typically high melting points, and they conduct in solution. Okay, covalent on the other hand, they are typically brittle, low boiling point, and they are non-conductive in any phase. All right, so if we come back out, let's take a look at what we got here. We see that A has a very low melting point, B has a pretty low melting point, C is getting a little higher. Boiling point here is super low for A, getting a little higher for B. C is pretty high, honestly. Okay, conductivity none and none as a solid, so at least there's a little bit. And in solution. So I would say that A and B are probably very covalent. C would either be a metal or a metalloid. And D is going to be our one that has all of our ionic things. It has a very high melting point, high boiling point, and its conductivity is in solution, which is really the kicker, which is really the dead giveaway. Because as a solid, that could be metal. And it's really not going to be ionic in that case. Because think about salt. It doesn't conduct in its solid form. It doesn't conduct as a crystal. But it does conduct when you drop it in some water. All right, so D is your answer there. All right, next one. Calculate the gram formula mass of NH4 3PO4. So what you're going to do here is set this up so that we have our N, our H, and our P, and our O. N's got 14 as our gram formula mass, and there are 3 of them. H, we have 1 as our gram formula mass. There is 12 of them. Don't forget that the 3 applies to the 4. The P, 32.1, and there's just 1 of them. And oxygen is 16, and there's 4 of them. So if you add that all up, and you should get an answer of approximately 149 grams per mole, give or take how you round it. All right, number 5, drawing the Lewis structure of LiCl and NH3. So let's do LiCl first. This is ionic. That means we have a transfer of electrons. And so that means I have Li, which starts out with 1 electron. And then I have Cl, which is 1, 2, 3, 4, 5, 6, 7. And then there's a complete transfer of electrons from the lithium. It gives it up completely. So then I have Li, which becomes a plus because it lost an electron, and Cl, which now has a full octet and is a minus because it gained that electron. And now if we go over to NH3, we are going to see that this is a covalent bond, which means we share electrons. And so I'm going to draw my N, which has 1, 2, 3, 4, 5 valence electrons. And then I'm going to draw my H's around it with 1 each. Okay, and then I'm going to share. I'm going to circle my unpaired electrons. And each one of those circles becomes a bond. So I have N with the 2 valence electrons, my H's all around, and my bonds. All right. Okay, so this question, why does CCl4 have polar bonds but is classified as a nonpolar molecule? Well, the simple answer here is electronegativity difference and symmetry. But let's break that down a little bit. So I'm going to zoom in up here, and I'm going to show you CCl4. So we've got carbon with 1, 2, 3, 4 electrons, and then we've got the Cl's around it. We have a tetrahedral shape here. 1, 2, 3, 4. And I'm just going to skip right to the bonding. Right there. Okay, so if we take a look at this, we do have an electronegativity difference between the carbon. Carbon is going to be like 2.2, and chlorine's like 3.7 or something close to that. But in any case, there is an electronegativity difference between them. So we have these polarities pushing out towards each one of the more electronegative chlorines. So we have this polar bonds from the electronegativity difference. Unfortunately, or fortunately, these guys are all symmetrical. So there's an equal and opposite force pulling from here to here, equal and opposite force pulling here and here. And because of that, they cancel out, giving us a nonpolar molecule. So symmetry saves the day and means nonpolar molecule. But we have E-neg difference leading to a polar bonding. Okay? All right. 7. Carbon forms a molecular compound with some elements from group 16. 2 of the compounds are carbon disulfide. Carbon dioxide is colorless, odorless, gas at room temperature. At standard temperature and pressure, CO2 changes directly to CO2 gas. Carbon disulfide is formed by a direct reaction of carbon and sulfur at room temperature, such and such as colorless, liquid, etc., and flammable. All right, so for CO2, identify one physical property. You have a plethora of answers here, but let's just go with colorless. Okay, and one chemical property. And you could say here that it is formed from C and O. Okay. For CS2, identify one physical property. Again, you've got several to choose from. You could say it's colorless, it has a bad odor, you can say whatever you want there. There's several that are acceptable, and the chemical property that is the most easily identifiable is that it's flammable. Okay. So state what happens to the potential energy of CO molecules during the phase change of CO. And the phase change here is that it goes from direct solid to gas, which is actually sublimation. And so if we have sublimation, the potential energy is actually going to increase. So we will have an increase in potential energy as we make that phase change. All right, so let's go on to our next here. All right, so we are calculating the heat released, that means Q, when 25 grams of water freezes at 0. Okay, there is no temperature change listed here. So because there is no temperature change, we know that we have a choice between the Q equals M heat of vaporization or Q equals M heat of fusion. So now it becomes whether it's 0 degrees, it is fusion or vaporization. And the easy answer here is to say we're not dealing with a gas, so it is not vaporization. So what you will do is take Q is equal to the mass, 25, times the constant of heat of vaporization, which is 334, and you will multiply that out, and you will get 8,350 joules. All right, so let's read this next guy. A hot pack contains chemicals that can be activated to produce heat. A cold pack contains chemicals that feel cold. Based on heat flow, state the type of change that occurs in a hot pack. Okay, so the type of chemical change. All right, so if you feel it being hot, that means heat is a product. Heat is released, and so that means it's exothermic. If a cold pack is placed on an injured leg, indicate the direction of the flow of the energy between the leg and the cold pack. This is weird you feel cold because the cold pack is taking heat from your leg to power the reaction that is occurring. The reaction requires energy. It's an endothermic reaction, and so it takes heat from your leg to the pack, making you feel the absence of heat and providing heat for the pack, the reaction that's occurring in it. So, what is the law of conservation of energy? Describe how the law of conservation of energy applies to the reaction that occurs in the hot pack. Conservation of energy means you cannot create or destroy energy. It can only be transferred. And that is exactly what is happening. There is a transfer of energy that happens in the hot pack. Heat is transferred, in that case, from the reaction out into the environment as a product. So heat is transferred, basically. All right. A 100-gram sample of NaCl has an initial temperature of 0 degrees. A chemist measures the temperature of the sample as it's heated. Heat is added at a constant rate. The heating curve is shown below. Determine the temperature over which the entire NaCl sample is a liquid. All right, so if we go through this, we've already gone through this once. This is solid liquid, this is liquid, and this is gas. So the entire range that it is a liquid only, that would be from C to D. So that is 801 to 1465. Identify one line segment on the curve where the average kinetic energy of the particles is changing. So anytime it is changing is on one of the diagonals. So you either have AB or CD, and either one is acceptable. Identify one line segment on the curve where it is in a single phase and capable of conducting electricity. Capable of conducting electricity means it must be liquid. And then single phase, meaning it can only be liquid. So this is CD. All right, the Greek inventor Archimedes and mathematician made several discoveries important to science. According to legend, Hero, the king of Syracuse, commanded Archimedes to find yada yada yada, consisting of gold, tin, copper. Archimedes measured the mass of each one of these, displaced the crown to see when it was submerged, repeated the procedure. Great. Archimedes was able to determine that the crown was not entirely made of gold without damaging it. Define one physical property that Archimedes used to compare the metal samples. You should hopefully be able to identify that this is density. He was measuring mass over a given volume. Density equals mass over a given volume. If they weren't the same, they weren't made out of the same material. And now determine the volume of a 75-gram sample of gold at standard temperature and pressure. All right, so what you need to know here is that D equals M over V. The density of gold is listed in your reference table, equaling the mass of 75 grams over a volume which you are finding. All right, so we are finding the density of hydrogen. It's here, and we need to round it to two significant figures. So I know that these first two zeros are not significant, so I can keep them. Let's put my decimal place in the right spot here. 0.0. And now I need to see that I need to round this properly. 89.9 rounds to 90. And so now, because I have a decimal place and a number to the left of this 0, it is significant. So I have two significant figures. All right, in terms of atomic structure, why does cesium have a lower first ionization energy than rubidium? Well, these two elements are in the same group. They are both group 1 elements, and rubidium is one period higher than cesium. So that means that cesium has another energy level. and it therefore has more shielding between it and the nucleus, more shielding, and will therefore give up its electron more easily. It has a looser hold on its electrons because they are further away from the nucleus. All right. As a neutral sulfur atom gains 2 electrons, what happens to the radius of the atom? So it gains 2 electrons, so it increases its negative charge, so its atomic radius will increase. After neutral sulfur gains 2 electrons, what is the resulting charge of the atom? It gained 2, so it is now a 2 minus. All right, explain in terms of electron configuration. Well, selenium and sulfur have similar chemical properties. They are in the same group, and therefore they have the same number of valence electrons. All right. Describe one appropriate laboratory test that can be used to determine the malleability of a solid at room temperature. This is an odd question, so don't overthink it. You can say bending samples, and be just fine with it. All right, now I also see that I am missing question 17. This must have been an older version of the same packet. So for 17, it will appear shortly. All right, so first off, we have a reaction type here, which I see is copper replacing silver and popping it off and making silver go by itself. So this will be a single replacement reaction. And now for the balance, we need to see that our coppers are just fine. Copper and copper. AGs look good, but my NO3s are off. So I'm going to put a 2 here, and then my silvers are now misbalanced, and so put a 2 there, and 1s everywhere else, and we're all set. All right, if you have further questions, bring them to class. Come see me before the test on Wednesday. Make sure you have a calculator and a pencil with you for the exam. All right, thank you.